Texan Global School. Limits. In this class, we will explore the concept of limits, laws, and continuity. We begin with the concept of limits. If f of x is defined as x approaches a, this means that it is defined on some interval containing a, except at a itself. And the limit of f of x as x approaches a is said to be equal to L. So it is possible to make values of f of x arbitrarily approach L, as close as you like, by taking x close enough to a, but not equal to that value. Let's look at an example. A function f is defined as f of x equals x squared minus 3x plus 4. We will analyze the behavior of the function for values of x close to 4, but not equal to 4. To perform the analysis, we tabulate proposing values that approach 4 on both sides as shown in the table. That is, values less than 4 and greater than 4. If we graph the function, we can see that when x approaches to 4, the function approaches 8. Using the definition of limit, we represent this behavior. We can see that when x approaches to 4 on either side, f of x approaches 8. Each limit has its own peculiarity, so we must consider possible calculating options. The first method is the one shown above, tabulating, approaching from both sides. Also, we can obtain the calculation of a limit by direct substitution, with the definition presented on the board. Some are calculated using algebraic and trigonometric tools, so it is important to review previous courses. Let's see an example. We will find the value of the following limit. We can see that if we send the limit by substituting the value of 2 in the function, what is called direct substitution, the value is not defined. So we will estimate the value of the limit by tabulating, approaching from both sides, when x is less than 2 and when x is greater than 2. If we graph the function, we can see then that if x approaches to 2, f of x approaches 0.2. Using the definition of limit, we can see that as x approaches 2 on either side, f of x approaches 0.2. This means that the values of f of x tend to get closer and closer to 0.2, while x gets closer and closer to 2 on either side, for x being different from 2. Instead of using tables, this limit can also be calculated using algebraic tools. We will factor and simplify. By sending the limit, we get the same value. We will now define the concept of continuity. Using the above definition, if f is not continuous at a, then it is said that f is discontinuous at a, or that f has a discontinuity at a. This means that a function is continuous if it satisfies the following 3 conditions where f of a is defined, that is, a is in the domain of f. The limit exists and the definition is fulfilled. Likewise, there are 4 types of discontinuity, which are removable discontinuity, which can be eliminated by redefining f at a. In this case, the function has a limit at a point, but with a different value. The jump discontinuity, in which the one-sided limits exist but are different. The infinite discontinuity, in which one of the one-sided limit is infinite and the other finite. Finally, the asymptotic discontinuity, in which both one-sided limits are infinite. In the previous example, when x approaches to 2, the limit is 0.2. Thus showing an removable discontinuity. We can see that if we send that same limit, but now at -3 in the same function, the value does not exist. Graphically, we see that it is an asymptotic discontinuity. As we have seen, we can approach a limit from the left or from the right. This is shown on the board. These are called one-sided limits. From the definition of a two-sided limit and one-sided limits, we conclude that if the one-sided limits are different, then the limit does not exist. In this example, we will use the given graph of a function g to obtain the one-sided limits. The limit as x approaches to 2 from the left of g of x is 2. Since if we follow the graph from left to right up to 2, the value that corresponds to it is 2. The limit as x approaches to 2 from the right of g of x is 1. Therefore, since the one-sided limits are different, the limit as x approaches to 2 of g of x does not exist. Now the limit as x approaches to 4 from the left of g of x is 3. And the limit as x approaches to 4 from the right of g of x is also 3. Therefore, since the lateral limits are equal, we conclude that the limit as x approaches to 4 of g of x is 3. On the other hand, there are various laws that can be applied to calculate limits. Essentially, we can add, subtract, multiply, or divide functions, or apply those operations to their limits. The limit of the power or root is the power or root of the limit. Also those related to constants, laws of radicals, and trigonometric functions. They can be verified with tabulations. Let's see some examples. We will evaluate the following limits. The first case, the limit when x approaches to 2 of x squared minus 2x plus 1. By direct substitution, we obtain that the limit is equal to 1. This means that it is a continuous function in 1. We can use the laws of limits. Applying the limit of the addition and subtraction of functions, we apply the limit in each term. When sending each limit, we obtain the same result, thus checking that the laws are correct. In this second example, by direct substitution, we see that the limit is not defined, so we will use algebraic tools for its solution. In this case, we will rationalize the numerator. By expanding using special products, the expression is simplified. Sending the limit by direct substitution, we obtain 1/10. In this last example, by direct substitution, the limit is not defined. So we will use trigonometric identities for its calculation. Let's recall the suggestion seen in the trigonometric identities class. Change everything in terms of sines and cosines. Expand and separate using limit laws. In this way, we can send the limit, thus obtaining 1.
Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com